Hi everyone, we're going to do a buffer in action problem. So the problem is we're adding a strong base, sodium hydroxide, to 1 liter of a solution containing sodium chloroacetate and chloroacetic acid. These solutes make up our buffer. So the first thing we're going to have to do is write a neutralization reaction. And remember, in a neutralization reaction, H or OH are always reactants. In this case, it would be OH. So I'm going to write down that OH is a reactant. And now I have to think about the buffer. Here's also some important information that would be provided to you from the appendix in your Harris text. So our buffer is a buffer containing sodium chloroacetate and chloroacetic acid. I would call this solute A-, and this solute HA. And which one of these solutes is going to neutralize a base? The acidic one. So OH is going to get neutralized by HA to form water and more A-. So some of this HA is going to get consumed by the OH. We need to figure out how much, so it would be useful to make an ice table. So if you add 1 molar of 100 mils of sodium hydroxide, how many moles of that? How many moles is that? I think that's going to be 0.10 moles of OH that we're adding. And how many moles of HA do we have in solution? Well, if you have 1 liter of 1.10 molar, wouldn't that be 1.1 moles of HA? And then how many moles of A- do we have? Again, if you have 1 liter of 0.755 molar, wouldn't that be 0.755 moles of A-? So notice that the moles of OH is less than the moles of HA, so OH is going to get consumed. It's the limiting reactant here. So reactants are going to go down by 0.1 moles, and products are going to go up by 0.1 moles. So after the reaction takes place, again, OH has been consumed. We've used up some of our HA. We only have 1.0 moles left, and we've made a little bit more moles of the A-. We have now 0.85 with an insignificant 5 moles of A-. So I think I would want to use the Henderson-Hasselbalch equation at this point. The pH is going to be equal to the pKa. They've given that to us. That's 2.865 plus the moles of A-, that's 0.855 moles of A- over the moles of HA. That's 1.0 moles of HA. And let me do the arithmetic here. I'm getting 2.79 with an insignificant 7. If you wanted to, you could call that 2.8. So that's a buffer in action. The most important thing to remember is that first step, which is to write a neutralization reaction. We'll do a lot more like this in class. Hope you enjoyed it, and thanks for listening.